Hello students, welcome to IMS Academy. In this session, I am going to do number of problems from analog circuits. But those questions I selected from GATE 2020. The session is very useful for electrical, electronics and instrumentation. In a simple way, I will do the questions, you will follow easily now. This is the first question. But this is the analog question in the year 2020, 2 marks from iron paper. Assume the diodes in the circuit shown are ideal. It's given all the diodes are ideal here. The current Ix flowing through the 3 kilo ohm resistor in milliamperes rounded off to 1 decimal place is dash. Is asking to measure the current. What current? Ix. The current Ix across 2 kilo ohm is asking. This current is Ix. This is only Ix only here. Across 3 kilo ohms. Totally 5 diodes are given here now. We need to identify what those diodes are going to be on state. But these 3 diodes are connected with 3 different input voltages. Other 2 diodes onwards we are going to receive here now the output voltage. Can you find all these 3 diodes to be on state? We cannot find. If all these 3 diodes are on, they must be replaced by the short circuit. These 3 are connected in parallel. Voltages will be different. This is an unbalanced circuit only now. Out of these 3, any one of the diode must be on, because input voltages of each diode is a different only here now. One must be on only now. So which diode is on, that is more important. In the same way, here the 2 diodes are given, 2 output voltages are given here now. Out of these 2, one diode will be on again. Which diode is on, I will explain clearly now. If the diode is ideal, the drop across diode is 0. If it is forward bias, that point is very important. If diode is a reverse bias, it can act as an open circuit because it can have the higher resistance. In that case, we need to replace diode with open circuit only now. So here the input voltages are given 3. Which diode will be on? You must check which diode is having input voltage of more, you check it now. That will be on only now. The voltage is more. The diode which contains input voltage of more will be on state. The rest of diodes will be off state only now. I mean, this diode is on, these 2 diodes will be off only now. Which contains high potential will make the diode to come to on very fast. This will be on very fast because of the input voltage more only. Next one, other 2 diodes are off. But in these 2 diodes, you check it now. The one is output is a 12 volts, the other one is a 6 voltage it is given now. Input voltages are given means you are selecting which voltage is higher. Output voltage is given, which voltage of the diode is low, you must check only now. This diode with a low voltage only now. That will be on. Output voltages are given means which diode with low voltage, that will be on only now. This will be off only possible. Because this node voltage, this voltage will help you to come to the on state only, we can say now. Anyhow, which is with low voltage, that will be on only now. Other diodes are off. In that case, I can redraw this network in this way. This is on, I said. This is with 6 volts. This is with 6 voltage only now. Diode is on, that must be short circuited. There is a resistor that is 2 kilo ohm. This is 3 kilo ohm here. This is on. This is 3 kilo ohm. That is 3 kilo ohm. Out of these 3 diodes, first diode is on only now. Which diode is on? First diode is on only, we can write now. The first diode is on, you can write like this now. This diode is on, short at 15 voltage. The remaining two diodes will be off. I can put like this now. This is open circuit only now. This is 10 volts. The next diode also off. This is a 5 voltage, I can say now. That is also off only now. And here 2K here connected here. This diode is off. This is having 12 voltage only now. Finally, we want the current of this denoted by symbol Ix only. How the direction is to be taken here now? The direction of the current. I can select the direction of the current in this way. I can select in this path only now. It is going to flow. It's going to flow current in this direction. Same Ix is going to flow only, we can say. How I can measure Ix? The difference of voltage by resistance only. Just we can apply the Ohm's law. Ix equal to, the input side I got 15 minus what current is passing across 3K, same current is passing across 2K. These two are in series only now. 15 minus 6 divide by total resistance 3 plus 2, 5K. 15 minus 6, 9 by 5. Okay. It becomes 1.8 milliamperes. It is going to flow now. 1.8 milliamperes it is going to flow. The answer is 1.8 millivolt now. So I can write 1.8. But anyhow, it is given in milliamperes only now. It is given 1 milliamperes only. That is the solution of this question only now. Such a way we can tackle this question now. Yes, 1.8 milliamperes. Exactly we are getting now. But I hope you followed. Anybody having any doubts regarding this problem? Anybody? Yes, next question. This is the next problem. But anybody can do this question? Please try this question and give your answer. I'll wait for some time. Please try this question. Anybody can do this question? Any student? Any student can do this question? Yes, what is given in the problem? Assume that the op amp in the circuit shown is ideal. This operational amplifier is set as a ideal op amp. The value of Vx by Ix is required. Input voltage Vx divided by Ix is asking to find. Vx by Ix. That ratio is required. How we can find that ratio is more important. I'll do then. Vx by Ix is required. When the op amp is ideal, V minus and V plus are equal only now. These two are equal. V minus equal to V plus. But a V plus equal to same Vx, same input voltage. V plus and Vx are same. This is Vx. V plus equal to Vx. Even V minus also same Vx. This is also Vx only. Both are Vx values. But I want here this voltage, I wish to take it as a V naught. If this current is Ix, same current is going to flow across 8 kilo ohm. This current can also be taken as a same Ix only. Same Ix I can put now. Same Ix. Same Ix is going to flow only now. But I wish to find what is Vx by Ix. But here I wish to take what is Vx at first. Because Vx I want here now. Vx equal to V naught plus drop across 8 kilo ohm. output voltage plus drop is nothing but the Vx only now. So Vx is nothing but V naught plus 8K into Ix. 8K into Ix I can put now. 8 kilo ohms into Ix I can put now. But without knowing the V naught, I cannot get Vx by Ix. Thereby required V naught. V naught in terms of Vx I want to get now. This voltage is also Vx. I wish to apply the nodal analysis. This current plus this current equal to 0 only, as per the nodal. So this current is nothing but Vx by 1K. Vx by 1K I can write, plus this current is nothing but Vx minus V naught. Vx minus V naught divided by 2K. I can write here now. This is equal to 0. K cancel here now. So 2Vx I can get. 2Vx. 1Vx. So 1Vx minus V naught equal to 0 I am getting here now. This you put as equation number 1 best, this V naught. 2Vx plus Vx is nothing but 3Vx I am getting here now. I am getting 3Vx only. Vx by 1K plus Vx minus V naught by 2K equal to 0 only now. But I am getting the 2Vx here, 1Vx minus V naught equal to 0 only we are getting. Finally 3Vx equal to how much? V naught I am getting here now. So V naught equal to 3Vx I got. V naught equal to 3Vx. Once again you check it, Vx equal to 8K into Ix plus this value. Okay, we got here now. So this value I want to substitute here now. Vx I want to find here now. Vx, substitute in equation number 1. Vx equal to V naught. V naught is nothing but 3Vx. 3Vx I got. Plus 8K into Ix I am getting now. 8K into Ix I am getting now. That value we got now. Catch my point. V naught, this V naught I want to substitute here now. Vx equal to V naught equal to 3Vx plus 8K into Ix only now. I want to divide by Ix. Divide by Ix here now. If you divided by Ix, first we can simplify, still we can simplify, I hope it now. What Vx we are getting from this? The total Vx, it comes as a 3Vx minus Vx minus 3Vx minus 2Vx I can get now. That equal to 8K into Ix I can get here now. Vx by Ix I want, directly we can get now. Vx by Ix I want. Vx by Ix. Vx by Ix equal to 8K by minus 2. It becomes the finally minus 4K, it is possible here now. Minus 4 kilo ohms it comes. Minus 4K is mostly possible. That is the solution of this question only now. That is the value. Kilo ohms is asking in kilo ohms only. Finally, we can put answer is minus 4 here. This is the required solution for this question. I hope you followed. If anybody having any doubt, they can post immediately now. I am ready to clarify. Just message, I can understand if you got any doubts. Okay, next problem. This is the next problem. This is also question from the analog iron gate 2020. Anybody can tackle this question? I will wait for some time. You please try this question. You please tackle this question. I'll see how many students can do this question. Please tackle this question. The question also from operational amplifier. But I want to know what voltage is possible, V1. Okay, I will do, please watch, you can understand clearly. Assuming ideal op amps, how many op amps are given? 2 op amps. Those 2 are ideal, it's given. The voltage at V1 in the figure shown is dash, is asking to find this voltage V1. What its value is asking to find. But in this problem, clearly given ideal op amps. V plus and V minus are same, you know very well. To measure the V1, conditions we need to apply. V plus and V minus are same. Same 3 voltage will be maintained here now. This voltage is 3 voltage. But this voltage V1 means same V1 you can have here also now. I want V1 value. And this voltage is nothing but V plus the 2 voltage, same 2 voltage you can have here now. 2 voltage only possible. Now you determine the value of V1. How we can find that node voltage? By using the nodal analysis only now. Just apply the nodal analysis, you find the V1 only now. How you can measure? This is a 3 voltage here it is taken now. This is a 3 voltage means same 3 voltage here also now. These 2 points will be taken as a single point also. Same point only now. Same 3 voltage I can have here now. These 2 can be taken as a single node point only now. How I can apply the nodal? This current plus, this current plus, this current equal to 0 only now. Summation of all these currents equal to 0. Directly you can put only now. How you can find that voltage? I can write this voltage is nothing but this side 3V by 1K. 3 by 1K. It goes to ground only now. 3 by 1K. Plus 3 minus V1 by 1K. This side current now. 3 minus V1 by 1K I can put here now. This current is nothing but 3 minus 2 by 1K I can write. 3 minus 2 by 1K. That equal to 0 only now. Try to understand. I am applying here nodal analysis by using the nodal. This current plus that current equal to 0 only take it here. 1K will be cancelled. 3 plus 3, 9. Sorry, here the 3 minus 2 is there, is it not? So here what I will get finally? 1K cancel here. Now 3 plus 3, 9. 9 minus 1, 9 plus 1. 3 plus 3, 6. 6 plus 1, 7 possible now. 3 plus 3, 6. 6 plus 1, 7 is possible. And I can get this equal to what? V1 only now. This side I can get a V1 voltage now. So finally I am getting V1 equal to how much voltage? 7 voltage. Just I will check this voltage. Yes, exactly 7 we are getting now. V1 equal to 7 voltage only. Just by applying the nodal analysis, we are getting that V1 only now. The solution of this problem. So you can put this is nothing but 7 voltage. Directly already given volts only now. 7 is enough. Volts also not required. 7 is just enough only now. That much value is possible now. I think you followed. But all the 3 questions are from IN. Now I will do the next question from the different branch. This is electrical branch. Anybody can do this question? It's a very direct question now. You please try this. I will wait. But I want to wait for some time. Who will complete this question? I will see. Anybody can do this question? This is very simple question. GATE 2020 analog question from the branch electrical. What is given? A common source amplifier with a drain resistance RD equal to 4.7 kilo ohms. Drain resistance is given 4K, 4.7K. Is powered using a 10 volts power supply. The voltage is given 10 voltage here now. Powered using a 10 volts power supply given. Assuming that transconductance GM is 520 microamperes per volts. In a problem, transconductance is given. There is a 520 microamperes per volts. The voltage gain of the amplifier is closest to what value is asking to find. Anybody can do this question without my help? Any student can do this question without my help. Is it possible? It's a very simple question. It is a common source amplifier is given now. For common source amplifier, you must understand the point. For common source amplifier, I'll write this now. For common source amplifier, I say. For common source amplifier. For common source amplifier, the gain is, but is asking the voltage gain is calculated by, voltage gain is given a symbol AV. Voltage gain for the common source amplifier is minus GM into RD. That formula they will apply. Minus GM into RD. This is a fixed formula for the common source amplifier now. That formula directly you can apply only now. GM transconductance is given in the problem. In a problem given, what is given? The transconductance GM equal to 520 microamperes per volts. GM is given in the problem. 520 microamperes per volt is given. And also drain resistance is given in the problem 4.7K RD. 4.7 kilo ohms only. Kilo ohms is given. Now directly we can substitute in the formula. The voltage gain is equal to minus GM. GM is nothing but GM is given in the problem. What is GM here? 520 micro. Micro means 10 power minus 6 I can get now. Into RD. RD is nothing but 4.7K. 4.7 kilo. 10 power 3 you will get like this now. But I want this voltage gain here now. If you are simplifying this, it comes as minus 2.44 mostly it comes now. Minus 2.44 mostly it comes. 2.44 is mostly possible. That is the voltage gain is possible from this question I can say. So which option is correct? Option C is correct here now. This is the right option for this question. I hope you followed this. Any students are having any doubts? Please arise. If you have any doubt, you can arise. This is the problem. And the next problem I want to do now. This is one more question. This is from the branch ECE. You please try this question without my help. You please try. I want to wait for some time now. You please try this question and give your answer. What answer you can get? What answer we can get? Anybody can message? Yes, I will do now. In the circuit shown below, all the components are ideal. All the components means here the op amp is to be considered as an ideal only. If Vi is 2 volts, this voltage is given Vi. This voltage is given 2 voltage only. The current I0 sourced by the op amp is dash milliamperes. Is asking to measure this I0. That current is required in milliamperes only. How we can measure this I0? This is from this point I can get output voltage of V0. I can get V0 value from here now. Once the output voltage V0 if you got, current is going to flow in this direction and reaches to the ground. That current I can take it as I1, for example. I selected I1. Because of this V0, some current is going to flow this side. This current I have taken I2 value. These are all conventional directions. If you got those two currents I1 and I2, positive means you can say right direction we have taken. If you got I1 and I2 minus, the direction will be opposite one now. The finally I0 is calculated by I1 plus I2. Addition of these two currents can give I0 value only now. In the problem strictly given, Vi is 2 voltage and also op amp is ideal only now. In this case, V plus and V minus are same. If this voltage is a 2 voltage, even this voltage is also same 2 voltage only now. This also same 2 voltage only now. Initially, I wish to find what is V0 here now. If this current is a I1, same I1 is going to flow this side also, no doubt. Same I1 will flow this side also. It is not going to divert any current this side. Reason? Op amp is ideal, input impedance is very high, approximately infinity we are going to put on now. Anyhow, the same current is going to flow this side. What is V0? I wish to find initially. By using the nodal analysis, I can measure what is V0 here now. Just nodal, this node I selected here now. This current plus this current equal to 0, I have taken for example. To measure the V0, just nodal I applied. This current means 2 by 1K. I can take 2 by 1K. I can put here now. What about this current? 2 minus V0 by 2 minus V0 by 1K. I can write now. 2 minus V0 by 2 minus V0 by 1K. That equal to 0 only possibles. I am getting this current plus this current equal to 0 only. 1K, 1K cancel. Finally, V0 equal to how much? I am getting 4 voltage only now. 2 plus 2, 4 voltage I am getting now. Yes, we got this voltage V0 equal to 4 voltage here now. By using this voltage, I can measure I2 initially. How I can measure I2? I2 is nothing but V0 by 1K. V0 is nothing but the 4 volts. Resistance is 1K. Finally it becomes 4 milliamperes. That much current is passing this side. What amount of the current is passing this side? I want to find I1. I1 is nothing but current across this 1 kilo ohm. I want to find what is I1. I1 is nothing but difference of this voltage by resistor. Difference of voltage is 4 minus 2. 4 minus 2 divided by 1K. Finally 2 milliamperes of current is passing. 4 minus 2 by 1K. It becomes 2 milliamperes. But we are in need of this I0. I0 is required here now. How you can measure this I0? I0 is the sum of these two currents, I1 plus I2. Sum of these two currents, I1 and I2. I0 equal to I1 plus I2. So I1 we got as say 2 milliamperes. The I2 we got as say 4 milliamperes. And finally we can say I0 is nothing but 6 milliamperes I can put now. 6 milliamperes. So I am getting solution 6 milliamperes. That is the answer for this question. Any students having any doubt regarding this problem? If you have any doubt, you can arise. 6 milliamperes we are getting now. I hope you followed. Yes, I did the questions which were asked in ECE paper 2020. ECE, IN and electrical. From these three branches onwards, I selected study number of analog questions. I did only now. I hope you followed. Thank you.